important for us to do it for all sorts of reasons, mostly mental math, if anything. Okay, so we're going to work through the first page together right now, and then that leads us into the second page, which deals with changing some lengths, units of measurement. Using mental math to multiply or divide by a power of 10. Okay, how are we with scientific notation? Do we understand scientific notation? Yes or no?
Yeah.
A little bit? Have you done it?
Yes.
Okay. I want you to show me how this works. I want to change that into scientific notation. You know how to do that? No. Okay, so that's where I'm at. So we don't actually understand how to do this. Okay, so scientific notation works like this. What you do is you take where your decimal place is, and you move it so that there's only one non-zero value to the left of the decimal. Okay? And each time you move it, you're multiplying by 10 to the power of something. So watch what happens here. And now this is important because we use this a pile in science, physics, chemistry, because you work with large and small numbers, very large and very small numbers, so we use this all the time. So my decimal's right here. We agree, right?
Yeah.
I'm going to move it one this way and one that way. So that is, I have now moved it two spots. And if I move the decimal to the left, I multiply it by times 10 to the power of 2. Each time I move it, that's what the exponent becomes. So now I want you to think about this for a second. What is 10 squared?
10 times 10.
10 times 10. What is it actually?
100.
It's 100. If I take 2.5 and I times it by 100, what am I going to get?
250.
250. That's why we put it into scientific notation. Okay? So each of these values here is basically a placeholder in which we move our decimal to. Okay? So let's look at this right now. It wants us to first, and here's the first one. I did it for you. So let's look at it on your page. You're going to fill these in on your page. So what is 2.5 times 10 squared?
250.
250. 78.26 times 10 squared.
7,826.
7,826. We agree? Okay. To change it, I'd move my decimal twice that way. And that's what I would be left with. So 7,826. Follow this so far?
Yeah.
Yeah? Okay. 4.09 times 10 to the 3. Okay, somebody else. Go ahead. 4,090. That's right. Okay. Now if I was moving the decimal place, I'm just going to change this to 4.09. If I move the decimal place, I go 1, 2, 3.
Because it's false.
There I have to put a 0 in there. Okay, so that's perfect. Good job. Here's one that's a little tougher. 0.006 times 10 to the third. Somebody else? Haley?
36.
Think it's 6? Okay, let's find out. Haley? 1, 2, 3. You're right. It's 6. Okay? Now, divide is a little different. So divide, I'm taking, okay, first of all, what is 10 to the power of 1?
10 times 10.
10. It's just 10.
No, we're not 10, I mean just 10.
Just 10. There's only one 10 there, right? So if I take 0.85 and I divide it by 10, what does that change this number to? Is that 0.085. Because if I'm dividing, I'm going to move it that way. So what do I end up with? 0.085. Okay. 982.6 divided by 10 squared. Harley.
9.826.
9.826. Great. Well done. Okay. 1, 2. Here's where I end up with. 1,760 divided by 10 cubed. Boy,
Would it be 1.760?
it would definitely be 1.760. Good job. Good work. 4.33 divided by 10 to the third. All right, go again.
0.0043.
0.0043.
Or I guess there's
Three.
another
Three.
3 too. Yeah.
Another 3 here. Do you agree with this?
Yes.
Yep. I think it's right. I would move it 1, 2, 3 to right there. I need those zeros in there. Perfect. So far, so good?
Yeah.
Ben, you following this?
Yes.
Okay. All right. Now, the most common units for length are meter, kilometer, and centimeter, as well as millimeter. The prefix on each unit name tells you how it relates to the base unit in meter. So kilo means 1,000. So then, therefore, the ratio of 1 kilometer to kilometer is how many meters?
1,000.
1,000. Very good. Okay. How about 1 centimeter?
0.001.
0,
0. Like, because that would be the
You think it's
1,000.
this? Yeah. Okay.
0, 1, that would be like the thousandth place.
That's
or
1,000.
Or yeah.
Which one do I want?
Oh, so,
100.
yeah, so that'd be one less, like just 1 0.
Okay, that's right. Perfect. That? Yeah. Great. Okay. And now 1 millimeter then would be
0.001.
0.001. That's
Yeah,
right.
that's what I meant.
Okay. We're all good?
I think they're on good.
Yeah? All right. Now, just before I go, I want to I like to work it the other way. I'm not a major fan of using the decimals. So when I set up ratios, I like to use basically whole numbers as best I can until I use the ratio. So what that means is this. I would sooner write it like this. 1 meter is equivalent to 100 centimeters. 1 meter is 1,000 millimeters. So if I'm using ratios to change things, this is the way that I would set it up. Okay? Excuse me. Thank you. So let's complete each relationship. So 10 kilometers is how many meters?
10,000.
10,000. Well done. 10 centimeters.
0.1.
Okay. Here's our first introduction to this. Yes. You can do this. I'm going to encourage you to do this math in your head. If you have the ability to do it, that's awesome. But what I want to do is I want to set this up for you so that when you get into grade 9 and 10 science, and we start changing actual units, which we're also going to do in this course. But for the sciences, I set this up a very specific way. I teach physics, so I need you to be able to convert quickly and easily from a variety of units. So maybe from kilometers to miles, miles per hour to meters per second. Those are not easy things to do unless you can get the very base as to how to do it. So I set it up like this. What I want to do is I'm going to multiply this by the ratio that I actually know. So I want to change centimeters to meters, so I put the meters on top and the centimeters on the bottom, like that. Okay, so far? Now I write out what my ratio is. So what's my ratio between meters and centimeters?
0.001. 0.
No, I don't want, I want to use the whole numbers.
Oh, so
So,
there would be 100 centimeters in a meter.
So 1 meter,
Because
As-
100 centimeters.
100 centimeters, correct?
Yes.
Now, if it's on top of the line, I multiply. If it's below the line, I divide. So I take 10 and I times it by 1,
It's 10,
which is 10. Then I take 10 and I divide it by 100.
which is 0.01.
No, just 1.
Yeah, 0.1. That's what I.
All right? And my units cancel out. As long as I have 1 unit on top and 1 unit on the bottom, they cancel out. So what unit am I left with when I cancel out my centimeters? I'm left with my meters. Okay? So we're going to try this again. So 10 millimeters times my ratio. So meters to millimeters. That way I cancel out. My millimeters go on the bottom and the top. Okay? What's the ratio of meters to millimeters now?
1 to 1,000.
1 to 1,000. Millimeters cancel with millimeters. 10 times 1, 10. 10 divided by 1,000,
0.01.
0.01 meters. Now, I know that you can maybe do this on your own and do it in your head without doing the stacking. But when it comes to you, what you're going to have to do is taking measurements and changing from centimeters to inches. It's easy to do this method. Okay? So we're going to get into that a little later this week or next week. All right, so let's go back to this. I'm going to do this a couple more times, and then we'll just go through it quickly. But 0.1 kilometer, I want to change it to meters. So I go like this, meters to kilometers. What is that ratio? Somebody other than Kayla. You're doing great, Kayla.
That would be 100. Like
What does kilo mean?
1,000.
So then what should this be?
1,000.
1,000 to 1. That make sense?
Yeah.
Okay. So I do that and that. Now I go 0.1 times 1,000, which is
100.
100 meters. Okay? All right? You still getting all these right?
I think so.
You think so? Okay. So I have 100 centimeters. Like I said, I don't need you to do this for these easy ones,
Yeah.
but it's practice that I'm looking for. I need to change that to meters, centimeters. What is that ratio there?
1 to 100.
1 to 100.
So it's just 1.
So 100 divided by 1 is 1 meter. Okay, and the last one, 1,000 meters, millimeters is how many meters?
1 to 1,000. So
1. That's right. Okay? So far, so good. All right. Complete the tables. Use patterns to help you. All right. So, can we fill in these charts, you think?
yes.
1 kilometer is how many meters?
1,000.
1,000. 2 kilometers is how many meters? 2,000. 3 kilometers?
3,000.
3,000. So far, so good. Somebody other than Caleb again. 1 centimeter is how many meters?
0.01.
Ben?
0.01.
0.01. How about 2 centimeters, Ben?
0.02.
And 3?
0.03.
Good job. Okay, Michael, 1 meter is how many centimeters?
1 meter.
1.
How many centimeters in a meter?
0. 100.
How many meters in a centimeter?
Meters or
Here's a meter stick. There's 1 meter here.
1.
How many centimeters are on that meter stick?
100.
So what's the answer? And 2 meters would be?
200.
And 3 meters?
Yeah.
You get what we're doing there?
Yeah.
Okay. All right. What about millimeters? How many millimeters are on this?
How many? I can't remember how many millimeters it is.
How many millimeters in a centimeter? How many of those little tips are there?
So it's 1,000.
There's 1,000.
And then 2,000.
Yes. Okay. That was down a little. Perfect. Okay. 1 centimeter is how many millimeters?
10.
10. 2.5 centimeters is how many millimeters? 25. 20 millimeters is how many centimeters?
2.
2. And 13 millimeters is how many centimeters?
1.3.
1.3. Great. Okay. One of the things that you are going to need for this unit will be a ruler, and it'll have to be one with centimeters and inches at some point. Kyle measured a can. His diameter of his can, so that's the distance across the end, is 67 millimeters circumference. Oh, sorry. I understand now. Diameter is 67 millimeters. The circumference is 21 centimeters. Okay, do you guys know what diameter and circumference mean?
Yes,
Yeah.
Diameter is the way
is-
the full way across, and then the circumference is like around.
Right, so the diameter is through the middle of the circle, right, all the way through. And it says that it is 67 millimeters. And the circumference is the distance around, so my circumference is 21 centimeters. So it says express both measurements in millimeters. All right, so this one's already a millimeter, 67. How many millimeters is 21 centimeters?
210.
210? Do we just times it by 10?
Yes, because that's how much millimeters are in a centimeter.
Right. There is 10 millimeters in 1 centimeter. Agreed? Okay. So what is, Dylan? 67 millimeters. How many centimeters is that?
6.7.
Nailed it. Good job. 6.7. And 21 centimeters is?
21
centimeters, right? Okay. Now, here's the part I said you guys are going to not like. I absolutely love fractions. Fractions is the difference between a great math mind and a good math mind. If you can do fractions, you can nail this. And anything, any aspect of anything. Okay, so it comes down to multiplication tables. When you're good at your multiplication tables, fractions should not be an issue for you. You struggle with it, that's where we have some difficulties. All right, first things first. I just want to talk about this. Raise your hand. Tell me how to do this question. Harley, go.
So you do 1/3 times 12 over 1, and then you just times the numerators and the denominators,
Times the numerators.
and then times the denominators.
Great work.
Oh, so I
So
did,
12 thirds.
okay. that's
So what is it?
12
4
thirds.
over 1.
1/3.
12 over 3. Right?
Yeah.
1 times 12, 3 times 1. Now, just wait. I'm going to come. You're absolutely right. You're absolutely right, Michael. My preference. I like to make things easy for myself in math. So I simplify before I multiply. The moment I see something on the top and something on the bottom that has something that like a divider that goes into both, I try and eliminate it, or at least make it smaller. So does 3 go into 12?
Yeah.
Make 3 more than 12, 4.
Yeah, that's right. So that becomes 1, that becomes 4. So 12 over 3 is
4 and 1.
4 over 1, right? Do I need the 1 on the bottom? No,
No.
no, I don't. Okay, how about 3/4 of 36? Michael, 3/4 of 36. Go.
Equals 144, 108 over 4.
108 over 4? How'd you get 36 times 3 so fast?
I did 30 times 3, and then I did 6 times 3.
Good for you. I like it. I like it a lot. Okay? So he took 30 times 3, then added it to 6 times 3, got 108. I love it. It's great. Anybody else want to tell me a different way of approaching this? Josiah, how would you do this question? You do like that? Kayla?
Well, you could simplify because like 4 goes into 36 8 times.
How many times?
8
Better get it right.
or 9, yeah, 9.
There. Now what am I left with?
3 times 9 is 27, and then just
That's it. Right? You tell me what's easier. 108 over 3 and then have to reduce it? Or just put 3 times 9 because I can reduce 36 over 4. I like to make math easier. Just my own preference. Makes me look so smart. Not really. It's just because I'm lazy. I don't want to do the big math. So, Haley, quick.
8 can go in 16, so that's 1 and 8. Or 2, sorry. 2. And then 5 times 2 is 10.
There you go. Easier or not?
yeah, that's quite a bit
Yeah.
easier than doing 8 or 5 times 16.
And then divided by 8. What do you think?
Yeah.
You like it? Don't like it? We're okay? It's a little bit better? All right, let's do this last one. 2/5 of 100, right? 2/5 of 100. Go. Somebody.
20, or well, you simplify 5 and 100, so it would be 20 over 10. Or yeah, 20 and 10. 20 and then 20 times 2 would be 40.
So there's no 10 in there.
Where'd you come from?
I don't know. I didn't say that right.
Okay. So 100 divided by 5 is 20. We can do that one pretty easy in our head, right? And then times 20 by 2 and we get 40. Okay? All right. Making equivalent fractions. So this is basically what I was just doing with you, right? So 3 times what gives me 15? 5. 4 times 5 is?
20.
20. Good. 6 times what gives me 3? This one I don't get.
You're
It
doing
should
it
be
backwards.
divided.
You don't think it should be divided? I think so too.
I think that you should do
So 6 divided by 2 gives me 3, right?
So
But, just wait, Caleb. So, on this one, I have 6 divided by something, and 3 over 8, right? So how do I go from here to here?
divide.
By 2, right? So how am I going to go from here to here then?
Times 2.
Now I have a times by 2, so what should this be?
16.
Okay? Does that make sense to everybody?
Yeah.
It's not exactly the way it's written in the book, so. All right. So 24 divided by 12 gives me 2. Ben, what's 36 divided by 12?
3.
3. You're right. Okay. 4 times 1.5 gives me 6. Oi, what's 6 times 1.5? How much?
13.
6 times 1.5?
No. 7. No.
9.
Come on, hey, you gotta stop. Okay, I know you're keen. I love it.
Yeah, because,
But I need you just to relax. I gotta get these things to work out. So I have to ask multiple questions to get the answer, okay? Okay, so Chloe?
9.
9. All right. What's 6 times 1, Chloe?
6.
6? What's half of 6?
3.
And then we add them together, we get?
9.
That girl. Okay? See how that works? I'm just trying to help everybody out at the same time. Okay. Linear measurements. Okay. It's common in Canada to see the lengths and distances measured using 2 different measurement systems. Not really that common. Not really that common. Most of our measurements in Canada are in metric. That's right. Okay? However, if you go to the lumber yard, more times than not, you're going to buy lumber in inches. Imperial, that's right. So we do have 2 sets. Okay? The metric system is used in Canada and throughout most of the world. The imperial system is also used in North America and the United Kingdom. Where have you used or seen the metric system for linear measures? So where do we mostly see it?
Stop like road signs and stuff.
Road signs, so Distances, right?
Rulers.
Lengths. Lengths, where else do we see metric measurements?
Weight.
Weight.
Mass? Weight? Mass? Which one's right?
Mass.
Mass. You know what the difference between weight and mass is?
Mass is like how much like it weight, like not weighs but like takes up,
How much space it takes up.
how much space it takes up, and then weight is like how much an object like weighs.
What do you mean?
Well, like I don't know how to say it, but like stuff can have mass but not weigh anything.
Is that? No, that's not right. Wait.
Well,
No, I'm confused.
It's beauty. Love this conversation because we talked about this in physics within the first 2 days. One of the biggest misconceptions that we talk about, how much do you weigh? Well,
That's not.
you're telling me that, okay, well, I say I weigh 67 kilograms, let's say,
and
right? That's not right.
pressure from the air
Not the air
and like gravity
The
and stuff
and the
takes off-
gravity and only the gravity.
takes like puts down extra force on you, so you would probably end up
Which-
weighing less.
Force is weight. That's the difference. That's why we have a misconception. I'm not asking you how much you weigh. I'm asking you how much mass do you have. Mass is measured in kilograms or pounds, but that's the amount of space you take up. You're absolutely right about that. Where weight comes in is when we take in the acceleration of gravity into the equation. So the force of you pulling down on the scale gives us a mass reading, but it takes into account the acceleration of gravity. Okay? Anyways, neither here nor there. What else do we use metric units for?
Like wrenches.
You can. Bolts, nuts, wrenches, right? There is some now. We never used to. You know what? It's pretty recent. I'm not saying like, I'm saying like 50 years recent, but it's pretty recent that we actually have millimeters in our measurements for wrenches and bolts and whatever else, because it always used to be in Imperial. All right? What about when you go buy
Like Christ.
milk? Where does milk come in?
Ooh, liters.
Liters. Is that metric or imperial?
Metric, cause
Metric. What's the imperial? What do they say in the
Ounces.
States? You're going to go buy what? Ounces or what's bigger than an ounce?
Quart.
Quarts.
Quartz.
Quarts. Right?
I was going to say
You got to go buy a quart of milk. They say that in the States. You watch that on TV. I got to go buy a quart of milk. That's imperial measurement. Right? We say, I got to go buy a 2-liter jug of milk. 4 liter if you have like 18 kids in your family. Like the Hanakis do, right? Right? Can't get enough 4-liter jugs. So there's another one. Okay, where have you seen the imperial system for linear measures? Where do you see the imperial system? I already said. Mostly.
like inches and like
Yeah, where do we use those terms? Mostly.
on a tape measure, like for I don't know.
ratchets, wrenches, bolts. No.
Okay, so you guys are talking what part? What are we using them for? What is McMahon and Yates?
Building store, like
Construction, lumber, right? Those are the imperial measurements. Those we still spend a lot of time working with imperial measurements. What is a 2x4?
2 inches by
4 inches.
4 inches.
2 inches by 4 inches, that's right. Okay, we're not saying 2 millimeters by 4 millimeters, are we? Yeah, pretty small. We're not saying 6.72 millimeters by 8.93, right? We say a 2x4. Okay? So those are some of the things that we want to cover. Okay. Next page, getting started. I'm going to leave you to that on your own. I want you to flip right to 2.1.
Straight to 2.1.
Straight to 2.1, which is page 38. And on page 38, we start talking about just the imperial units. So the imperial system measurement evolved from a system used in ancient Rome based on reference from the human body and everyday activities. This is actually quite neat. This is quite neat. People don't know this history. Where does the imperial system come from? Here it is. 1 inch. Why? It said it was the width of a person's thumb. 1 foot. The distance from a person's heel to his big toe. That's where it comes from. My foot's not the same size as somebody else's foot. Right? So I don't know who the first dude was, but they had it down. That guy's foot is 12 inches.
Some big feet.
Some big feet. Not mine. Somebody else's.
Fashion sisters, Nathan's feet.
Yeah. 1 yard, the length of a person's stride. That's where that comes from. Often these units were based on an important person like a king. This resulted in units that were different in different regions. In 1824, the units were standardized and became the imperial system of measurement. Write the 4 units of imperial measure above in order from largest unit to smallest unit. So how do we go?
Mile, yard.
From largest, go ahead, keep going, you're doing it.
Mile, yard, foot, and then inches.
Mile, yard, foot, inches. That's right. How many inches are in 1 yard? All right, let's go. I want to do this quickly, and then I'll give you some time today. It's Friday. Give you some time today just to kind of process all of this. But here's what I want you to see. It asks you how many inches are in a yard, right? So I have 1 yard right here. Now, eventually you're going to get really good at this, and you're going to say, well, I already know that there's 36 inches in a yard. But for right now, I'm going to treat it as if you don't know that there's 36 inches in a yard, but you do know how many feet are in a yard. And then you're going to tell me, well, this is the number of inches in 1 foot. All right? So, how many feet are in a yard?
3.
3 feet in 1 yard.
And 3.3 feet.
And how many inches in a foot?
12.
12 inches in 1 foot. Now I want you to look at the board, please. Yard up top, yard down below. Cancel. Foot up top, foot down below. Cancel. What are the units that I'm left with?
312.
What are the units I'm left with?
Inches.
Inches. There's my inches right there. Multiply across the top, divide by anything on the bottom. 1 times 3 times 12 is 36. Divided by 1, still 36 inches. Okay? Questions about that?
From converting from imperial to metric, I know this is like a bit ahead.
Yeah.
But isn't 3.3 feet equivalent to a meter? Wait.
Oh, well, I'll tell you what. Just because you asked the question, we're going to figure it out, okay?
Okay.
So, 1 meter. In order to do this, we're going to change it. I want to know how many centimeters are in 1 meter. So how many centimeters in 1 meter?
100.
There's 100 centimeters in 1 meter, right? Okay. Here is the units that I change. Okay, this is what I change. All right, from metric to imperial. I use this next conversion to do it. Here it is. I have 2.54 centimeters.
Oh, 2.54.
Just wait. In 1 inch.
Yeah. I
Yeah.
thought it was
Okay, so now that I have inches, I need to change inches to feet, right?
Mhm.
So I have a foot up here. I have 12 inches down here. Just like that. Okay? So I'm changing meters into feet, right? So right now, I want you to take your calculator out. You have it out? Take 100 divided by 2.54, sorry. 100 divided by 2.54 divided by 12.
3.2808398.
3.281.
808.
Yeah, perfect, thanks. So to answer your question, you were almost right on in mine.
Good job, man.
3.281 feet in meters. Okay? All All right? This guy right here, this is where we're going to. That's down the road. Can we convert from inches to centimeters can we convert from imperial to metric and metric to imperial? We use this guy right here as our basis. Okay? So go back to the page here. We have 3 feet in a yard, 12 inches in a foot. There are 36 inches in 1 yard. So number 3, how many feet are in a mile?
3.
So,
Sorry, 5,200.
Those are big feet. Really big feet.
all right. 3 feet to a yard. How many yards in a mile? 1,760. Write that down. You need to be filling in this information, man.
Oh, that's right.
I know that, but you're at the bottom of the page filling it all in. It's part of getting this all done. So I take 1,760 yards and I times it by 3 feet, and what do I get?
5,280.
5,280 feet in 1 mile. Okay? How are we doing? Good. Okay. One last one here. Column is 5 feet 11 inches tall. I didn't give anything. How many inches is column? Okay. Somebody want to tell me how you would approach this question? Ben, you start.
For me, I've always known that 5 feet is 60 inches.
Okay, so you would convert 5 feet. 12 inches in a foot gives me 60 inches.
And then
That's
add
great.
on 11 to that. And
Add on 11. And how many inches is he?
71 inches tall.
Beautiful. Great work. Great work.
Can I move the washer?
I'll wait till we're done. Okay. What is Colin's height in inches? Well, we've already done that. 5 feet times 12 is 60 inches. 60 inches plus 11 inches is 71 inches. We've got that. All right. This next part right here. This is the meat and potatoes. Sandy is building a staircase with 8 steps. Each step is 7 1/4 inches high. What is the height of this staircase in feet and in inches? Okay. So first things first, we have 7 1/4 inches, and how many steps do we have? 8. So I'm going to do this. Let's do this without a calculator to begin with, okay? 7 1/4 times 8. How do I multiply that? Harley.
You turn 7 1/4 into an improper fraction.
And how do I do that?
Well, you'll do 7 times 4, which is 28, and then add 1, so 29 over 4.
Great work. 29 over 4
And
times
then times it by 8.
8. Okay? Now what am I going to do next?
Well, times 29 by 8. And
Yeah.
then, which you could do 30 times 8, and then subtract 8, so that'd be 232.
You think it's 232?
Mm,
Okay. You okay?
okay.
And then it's over what?
Over 4.
Over 4. So reduced, it's what?
3, 20 or 28.
Okay? You're close. Close. Great job. I love the way you're thinking. You're thinking exactly like a math person. Let's do this easier. What did we just learn today so far?
You can do that.
Does that work?
Yeah,
Okay? What do you think? Was that easier?
yeah.
I like the way you thought that through. That was awesome. I'm going to give you one more. Think this through. What's 1/4 of 8?
2.
2? Right? What's 7 times 8? 56. And a quarter of 8 is? And what's 2 plus 56? 58. Another way to think about it. That's why I love fractions. There's multiple ways in which we can do this. Some are easier than others, but you're still doing it up here and not punching it into a calculator. I like it. I like it. There is moments where we need calculators. There's no doubt. Okay, so I've got 58 inches, and it says, what is the height of the staircase in feet and inches? We got it in inches. Okay, now I need to change 58 inches into feet. What is the ratio?
Feet is 1 and inches is 12.
Okay, so now I have 58 over 12. We agree?
Yeah.
That's how many feet there are. Let's put that in so that I get the amount of feet I can possibly have, and then whatever's left over is 1/12 of an inch. Okay? So, mental math. How many 12s go into 58?
4.
And 4 times 12 is what?
That would be 48.
So 58 subtract 48 is what?
10 inches remaining.
10.
So there's 10 inches remaining. So 4 feet, oops, let me do this again. 4 feet, 10 inches. Would you agree with me?
Yes.
Is that right? Yeah. How we doing? Good. We done a little bit of this last year? Or is this pretty new to you?
Pretty new.
Pretty new?
Yeah.
Perfect. Did you just learn something today?
Yeah.
Mhm.
For sure.
Awesome. Awesome. That's the whole battle right there. Okay? So don't go home and tell mom and dad, nothing. Didn't learn nothing today. Because you learned lots. Learn lots. Okay? Finish off page 36 and 37. If you can get started after that onto the page 40, then so be it. If you don't, that's okay. So 36 and 37. Good work today. Now you can go, yes. Does it bother you guys? You hear all the kids outside playing for recess, and you guys didn't have recesses anymore?
Mm.
I mean, back in grade 8, we already had breaks.
Oh, wow.
We only had one shower.
Considering they all go over there.
Oh yeah, I suppose.